Is it possible to build a 3-kilometer tall building? Considering we are living in a century where anything is possible, well, we can say it is theoretically possible without even putting much confidence saying that. The question is, why do you even want to build a structure that high in the first place? But for the sake of those who are curious about building a 3,000 meter tall building, which would be 3.6 times the height of the tallest building in the world, Burj Khalifa, let's see if this is indeed practically possible or not. Just to put things into perspective, the average height of a room is 3 to 4 meters high. Now, if you are building a 3-kilometer high building, which is 3,000 meter high, this will mean you will need 900 to 1,000 floors inside the building. That is insane. Don't forget that the Burj Khalifa has 160 floors and people still wonder how this was achieved. Talk less more of having a building with 1,000 floors. A 3-kilometer tall building will definitely be pushing design and construction limits and will also be economically suicidal. Let's see some of the challenges that building so high can face. Building a structure this tall will be under a huge amount of wind force, and I'm not saying that it is not possible to resist. We can resist it, but with intelligent engineering. In such cases, wind tunnel tests are conducted and the shape of the building is put up in such a fashion that we can reduce the wind forces. For example, the current tallest building in the world, Burj Khalifa, is standing under the same principle. We know wind force increases as the height of a building increases. And if the building height is like that of Burj Khalifa, then the allowable deflection is 3 meters or so, which can make the people inside the building uncomfortable. So, engineers regularly change the profile of tall buildings so that the boundary layer of wind that is formed around the building will get confused with height because of the change in the shape of the structure. This reduces wind force drastically and helps the tower to remain upright. The lateral forces are simply carried by the tower frame and spinal wall system. But in this case, we are talking of a building 3,000 meter high. Once you get past 1,000 meter high, the wind forces become so disastrous. You also need to consider that after 2 kilometer high, breathable energy becomes scarce, and after 2.5 kilometer high, nothing can really be visible on surface due to cloud and atmospheric effects. This will really pose some engineering hurdles and difficulties. We all know how devastating earthquake can be. But don't worry, taller buildings perform better and show much more anticipated deformations during earthquake than shorter buildings. But wait, is that really true? The probability of failure of a structure depends on the way it was engineered. It is not as easy as it sounds or feels. Designing a structure to resist earthquakes lies under a lot of assumptions. Straight from the analysis approach, assumptions in code and probability of earthquake, a building might collapse if it has one of the following. Ground motion or ground acceleration or intensity of earthquake is higher than what is calculated. A design level earthquake is the one that has the probability of incidence of 2% in 50 years. Why 50 years? 50 years because that is the assumed life of a building. If we have an earthquake stronger than the design level earthquake, then there are chances that a building might collapse. Low ductility in the building. If the building is designed without any ductile detailing of reinforcement and not even single monitoring during construction, then that building, regardless of it being a tall or low-rise building, has more chances of collapsing than any other structure. Then irregularities in building. If the building has a couple of very short columns, then during earthquake they will end up taking more load and collapse because of this high shear demand. And if there is a presence of weak story that has stiffness less than compared to adjacent stories, they will drift way more than other stories, and this will have a higher chance of collapsing. If the structure is very irregular, then the load part will become complicated and that may lead to structural failure. So designing this building to withstand strong earthquake ground shaking motion will also be a real challenge for the engineers. If you have to build a structure 3,000 meters high, then you will need a strong foundation. This foundation will be a combination of raft and piles. The foundation will be several feet thick and the piles will be drilled at least 150 to 175 meters deep into the soil. This will make the total depth of foundation equivalent to 175 to 200 meters deep from the lowest floor. I am saying the lowest floor because the building is so huge. It will require several stories of parking. The foundation of Burj Khalifa, which is 828 meters, has piles driven about 50 meters into the ground and has raft which is 3.7 meters thick. Now, you can imagine why we require such a giant foundation. The foundation of Burj Khalifa looks something like this. As you can see, the plate you are looking at is a mat, while the tube are piles which are driven into the ground. So the foundation of this structure will be so massive that it will use more concrete and steel than the largest modern structure ever built. This could be economically suicidal. It takes around 10 minutes to reach the top of Burj Khalifa, that is the highest occupied floor, located at 585 meters from the ground. Because this height of 585 meters is so high, you can't just use one elevator to move from ground to the top floor. You have to switch elevators in order to get to the highest floor. So imagine the same thing for a 3-kilometer tall building. We will require many more elevators with transfer levels. In a building like the Burj Khalifa, there are 57 elevators. So in such building, we will require anywhere around 150 to 175 elevators, assuming that the elevators are much faster than elevators used today. You also need to provide as many stairs as possible. Therefore, in order to provide this many elevators and stairs, we will require a huge central space around, which we can construct a core wall or a lateral force resisting system. These massive walls can resist the lateral forces, but to provide this many elevators will really be a challenge for engineers. If such a tall structure will be constructed, then it will obviously be a misuse building, which leads to the question of how will they deal with the issue of parking. Several floors for parking will be needed for the residents. And in order to make everything quick so that people don't have to drive 15 or 20 or 30 stories into the ground or above the ground, we will have to work with automatic parking systems where you stop your car at designated location, then there will be an automated machine that will take your car to an empty spot. This automated machine will do the parking and park your car in any available space. Then you will be able to track the parking spot. This is the only way to make the system efficient using this automated parking system, and some buildings have already adopted this parking system. How will residents living inside this building deal with fire outbreak? In case of a catastrophic fire, we will have to think of something innovative where people don't have to come all the way down to the ground in case of a fire. This is where we will have to adopt the concept of refugee rooms. These refugee rooms has been adopted in tall buildings where there are big fireproof rooms constructed at every floor levels where people can lock themselves in and wait for firemen who can rescue them. Apart from this, we will require strong pumps to pump water to the top of the building. With this idea in mind, we can say building this high can be achieved, although it will be really challenging. If you want to construct a 3-kilometer tall building above the ground, you will have to pump concrete up to that level. Now, we have pumped concrete in Burj Khalifa, and guess what? It is not up to 828 meters, rather it is up to 600 meters. Now, imagine trying to pump concrete to a height of 3,000 meters. It will really be difficult and challenging. We will face a tremendous amount of challenge to pump it up to 3,000 meters without letting the concrete dry, even if we add admixture to the concrete. So this will be something we will need to consider before deciding to build a structure as high as 3,000 meters. Although there are other factors which we will need to take into considerations, but these are the main factors. So it is not as easy as it sounds to build this high. But as the saying goes, imagination is a beautiful thing. It can take us anywhere, but it is reality that limits us. What do you think about building a structure this high? Let us know in the comment section below. Do you think it will be practically possible to build a structure 3,000 meter high? Give us your opinion in the comment section below. We would love to hear it. If you found the video informative, I will appreciate if you can give the video a like, share with friends, and subscribe to the channel Innotutorial for more construction videos like this. With that being said, you all have a beautiful and wonderful day. God bless you all. Bye bye.